Hi folks, Mr. Long here with another screencast. We're going to solve another one of these fun circle line intersection problems. We're going to look at the line 4x plus k. So our y-intercept is a parameter. We don't know what the y-intercept is. We want to make sure that the y-intercept is picked for this or selected such that, or so that we get a tangent, right? So it just touches a circle in that one spot. Because if k is bigger, if it's up here, then it won't intersect at all. And if k is, say, down here, below that point, it's going to intersect twice. So we want to create a tangent that just touches it once. And the slope is fixed at 4. And the radius is fixed at 11. Because it's x squared plus y squared is 121. So let's start working through this. So we know that we've got 4x plus k, and we know that at the intersection point, right here and right here, we know that the y value on the circle is exactly the same as the y value on the line. So I can do some substitution then. I can replace the y value in the circle with the y value of the line. So I have x squared plus, in brackets, 4x plus k, quantity squared, equals 121. And now I need to expand x squared plus, and I'm going to show it with two brackets, 4x plus k, 4x plus k equals 121. And now I do what's called FOIL. To expand that out, I'll just make that comment here. So FOIL is the first. And let's just circle the first term, so 4x and 4x. So I've still got my x squared to start, then 4x times 4x is, 4 times 4 is 16, x times x is x squared. And next I've got first, and now I do outside, so 4x times by k. So 4x multiplied by k. Now, I could write it as 4xk, or 4kx would also be accurate. It's better to use 4kx because x is the independent variable, and we know that traditionally coefficients go in front of the independent variable. Okay, so 4kx, now I do the inside. To do the inside, I'm going k multiplied by 4x. So same sort of thing, plus 4kx. And I do the last terms, which are k multiplied by k, plus k squared. And altogether, that adds up to 121. So what I need to do now is to simplify that. So I've got like terms here, I've got like terms here, and strangely enough, these are like terms, the k squared and the 121, because that k is a parameter that represents a constant value, the y-intercept. Right? It is that y-intercept is a constant, so it fits in with the 121. So as I work through this, I'm going to end up with 17x squared, 1x squared plus 16, plus 4k and 4k represents 8k, x plus k squared minus 121. I'm putting all terms on the left side of the equation. That's going to equal 0. So now I have it in the form a x squared plus b x plus c equals 0. And I can use my idea of discriminant. So let's just look at this. So a would be 17. B is 8k, and C is k squared minus 121. So let's go to the next page and take a look at this. And the question here is, the discriminant is 0. And why is the discriminant 0? Because we know that when there is one intersection between the circle and the line, the discriminant will be 0. So I know that D equals 0 for one intersection. So discriminant equals b squared minus 4ac And in this case, we know that our b value is 8k squared minus 4. Our a value is 17. And our c value is k squared minus 121. And that again is set equal to 0. And now I expand this bracket out. So 8k squared is 8 squared k squared. So 64k squared minus, and then I do, in this case, I do 4 times 17 times k squared. Negative 4 times 17 times k squared. And that works out to 68k squared. Lastly, I do negative 4 times 17 times negative 121. Two negatives will make a positive. So negative 4 times 17 times negative 121. And that will work out to 8,228. And that equals 0 because we're creating a tangent. We want a tangent. Next step is to simplify this. Negative 4k squared plus 8,228 equals 0. And now I need to solve. And here's where inverse operations are really nice to know. If we look at this, let's see, and I'll just do this in a different color. For regular bed mass, so if I'm going to forget about the 0, what I would do first, exponents. So the first thing I do is square. The next thing I would do is multiply by negative 4, and the last thing I would do would be to add 8,228. Well, what are the inverse operations for that? Well, what is the inverse? Our last step would be to add 8,228, so our first step is to subtract 8,228. The next step after that would be to, instead of multiplying by negative 4, to divide by negative 4. And the third inverse operation would be to square root. So when I look at that, I can immediately go to my answer and know that k is going to equal, the first thing is negative 8,228. The second thing is to divide by negative 4. And the last thing to do is to square root. And we know we'll have the plus and minus cases. So in this case, k equals plus and minus 45.4. So the y-intercept on that line, if it's 45.4, with a slope of 4x, will be tangent. So I'll just write that here, the last little bit, instead of going on to the next page. The equation of that line, which is a tangent to the circle, will be 4x plus or minus 45.4. And we should, really think, is it reasonable or not? And I guess the best way to know if that's reasonable is to think the circle has a radius of 11. Look back at your sketch. And then from there, we know it's got to be much higher or much lower. So that seems to be a reasonable number. Okay, folks, so that's how you work through this and determine the y-intercept on a line to make it a tangent to a circle using properties of discriminant.